I was just thinking about CO2 as we walked around here, of carbon dioxide, and I was wondering how much does it vary? Because we get this number that, I mean, is it 400 parts per million that we're at now in the planet?
A bit more than that, yeah.
How does that vary over land, over sea, over city? Is it more or less consistent, or is it?
No, you get very, very big domes. They talk about domes of CO2, which you can see from satellite over cities, because that's where the fossil fuel burning is happening. In the plume, of course, of something like a smelter or a power station, you're going to get very, very high values. You get hemispheric changes. So there's a slow sort of wave, which is, if you look at the classic CO2 trace.
It's seasonal, isn't it?
You see in the northern hemisphere, you see that seasonal trace. So it's highest at the end of winter and lowest at the end of summer, because the whole hemisphere, northern hemisphere, these plants have been drawing down CO2 throughout the length of the growing season. So the lowest point is at the end of the northern hemisphere summer, then it comes back up again. And of course that wave pattern varies a little bit. If you've got a very strong disturbance to the weather, people will probably have heard about El Nino and those kind of disturbances. That can make a difference too.
Okay. I think it just shows how everything is interconnected.
Yeah.
And that's why carbon dioxide for trees can't just be a good thing, because it comes with all these other knock-on effects that you wouldn't even begin to think about.
Yeah, definitely. It's very, very complicated. So what's the impact you're seeing on the food web then? Is it just things a bit to do with leaves, or are there any other things?
That's the strongest thing. Yeah, no, that's the one kind of categorical result that we've seen that's kind of popped out as a statistically significant change. Other things we're not. There's so much variability in a semi-natural environment like this that the signal isn't quite popping out. We're seeing changes below ground in terms of the community of living things, but things that are a little less charismatic than bugs. So we're seeing an increase in the mass of microbes per gram of soil below ground. So that's telling us that the system, the community, is part of the thing that's happening here, is that carbon coming in at the top of the dominant plants in the leaves is being used throughout the plants, but also exported through the root system into the soil. And the reason that plants do that is because if they can afford it, if they give away some carbon in the form of sugar and amino acids, that stimulates particularly fungi to provide nutrients, particularly nitrogen and phosphorus nutrients, back to them. And the plants can't get those nutrients any other way. So it's a symbiosis, a communal response, and surprisingly strong response actually for a forest like this, which is 175 years old just in terms of its oak trees. It's older than that in terms of how long it's been a forest. And one of the questions we had right at the very beginning was, is this forest going to care at all?
Yeah.
It turns out it does care, and it is agile enough. So as a set of middle-aged oak trees, I'd say they're a good deal more agile than I am as a middle-aged man in seeing that step change in CO2 and responding to it.
It's incredible. What's that, in 5 years worth of data?
Yeah, so this program's been going 5 years, so as you say.
Well, 2017, so we're in 2021 now, aren't we? So we've got 2017, 18, 19, 20, coming to the end of the 5th year. Emma's arithmetic's much better than mine.
It was a lucky guess.
Yeah, so we started in 2017. The elevated CO2 goes from, it depends on the leaf flush and the leaf fall, but it's basically from the beginning of April to the beginning of November.
Okay.
We don't add the carbon dioxide in the winter because there is nothing that a leafless plant can do with carbon dioxide. And we don't add it at night because photosynthesis requires sunlight, and so there's absolutely no point So just to not to be wasteful. It's
Yeah,
during the day,
not put
during
more
the
up there.
exactly. Yeah, we don't want to be sort of silly about it.
Exactly. But it is quite promising. In a way, it's promising about what's happening with the soil, I think, especially as we talked a lot in this series about regenerative agriculture and that type of thing. So if we're seeing trees being able to put more back into the soils, hopefully paints quite a good picture that actually a lot of these things are fixable. Some of the issues are going to help create solutions, and if we're smart, and we start increasing tree cover and things like that, fingers crossed, I'm hopeful that will at least contribute a little bit to the recovery.
Oh, absolutely. And I think a lot of our big stories are going to come from below ground. Carbon, nitrogen and phosphorus budgets, once we see those playing out, it could well be that actually in this forest, which is we would hope that this is a pretty healthy kind of forest soil. If this can respond well, then I think in the situations that Emma is dealing with, where we're often dealing with very much more impoverished situations, there might be lessons that we can learn and transfer into that.
Yeah.